Yesterday's work. What can I do? Yeah, 20. That's what I was figuring. Okay. So average rate of change is the same as the slope between the endpoints. So it's like slope where you actually have 2 points. It's not an instantaneous place. So, if I have something like this and I have a point here and a point here, the average rate of change would be whatever the slope of this is. The instantaneous, I can take it like any 1 point, but the average is just the slope between the 2 endpoints. So I've got -4 comma something, and I've got 6 comma something. That's my 2x values, and I've got to first find the y values that go with those, and then find the slope in between those 2 points. So when x is -4, I got to find out what y is. So I'm working with g. G is right here, and I'm going to plug in the x value. So if I plug in the x value, it says the integral from 2 to -4 of f of t. So plugging in -4 gives me this. Well, I can solve this. I can figure out what this is. So I can find the area between -4 and 2. So 2.5. That one is 1. That's 2, 4, 1.5, 0.5. I might have them written down. I checked them and I'm right. Let me go to it. Okay, so I'm going to go from -4 to 2 just because that's what I'm used to. That's the direction I typically go. But these are reversed, right? So when we get to the head, we're going to have to change the sign. So I got positive 2.5 minus 1. So 1.5 minus 2 is -0.5. Plus 4 is 3.5. Wait, no, sorry. 1.5, -0.5, -4.5, -6, -6.5. But again, I feel like I'm going too fast. Does everybody have it and they know that's right? It's 5. This part? 1, 2, 3. Oh, it's 4. Okay, so those are going to wipe. So I got -3, and then -2 more. So I believe that's -5. But what I'm saying, and no one is freaking listening, is that right? Like, you guys have the answers pulled up, or you did it? Okay, okay. You didn't do it that way? What'd you do? So then you have to find g of 6 and g of -4 then. Okay. So, all right, so if I plug in 6, now I'm saying what's the integral from 2 to 6 of f of t? So from 2 to 6 is between there and there. So this part down here is 2. This part up here is 1.5. So this would be -0.5. And then once you have those, you're doing like the old slope formula. So y2 minus y1, so like -0.5 minus -5 over 6 minus -4. 2 to 6 minus 3. is going well. Sorry, what's this? 3. And it's -3. You gotta flip it because it's backwards. So then, okay, negative -0.5 minus 3 over 6 minus -4. So like negative 3.5 over 10. You can leave it like that. I kind of bubbled up the counting and stuff, obviously, Izzy, but does that make sense? Like what I'm supposed to do? Okay. And then find the instantaneous rate of change of g at x equals 5. So that is basically saying find g prime of 5. So remember that the graph we're looking at is g prime. Because if we took the derivative of both of these, it would tell us g prime, because the derivative of g is g prime. And the derivative of the integral of f is f. So this graph is g prime. And it's saying find the instantaneous rate of change with respect to g when x equals 5. So g prime of 5. So you literally just read this graph. That's 1. So you're just like plugging 5 into the graph and you get 1. Is that part okay? Part C, where is g concave down? So g is concave down if g double prime is negative. Well, I have g prime. So how do I get graphically? How do I go from g prime to g double prime? Derivative. So take the slope. So I want to know where the slope is negative. So I'm going right here. So from -4 to -1, g prime has a negative slope, which means g prime has a negative derivative, which means g prime prime is negative, which means concave down. So that'd be -4 to -1. Is that part okay? And then D, can I erase? Or are people still writing down? Because it's just like there's just a point there at the end. It's not an arrow. I wouldn't worry about that. About can you go to part D? Find all intervals where g is a critical point, and then tell me if it's local max, local minimum. Okay. So remember, this is g prime. So critical points happen when the derivative is 0. So right there and right there. This one, so at x equals -2, is that a relative max or relative min? It's a max because prior to that our derivative's above the axis, so we're increasing. After that we're below, so we're decreasing. Remember, this is g prime. And then x equals 4 is a relative min. So your justification will be like g prime changes from positive to negative, and then here if you g prime changes from negative to positive. Any question on that? Are you good? Any question on that I go over again? Okay. Other ones on 6-6? Yeah. One. That's still 15. 2 to 6. Okay, so I would look at f of x, 1 to 2, 2 to 1 to 6. So I'm going to be using these. So I'm going to look at like 1, 2, and 6. And this is telling me between 1 and 6, that whole thing adds up to an area of 4. Between 1 and 2, that part is -2. And then they're saying, okay, between 2 and 6, what's the integral? Well, it has to be true that this plus this give you the 4, so it's got to be 6. It's a terrible 6. Does that make sense? What up? It was pretty bad. Any other? All right, let's go 6 up. Get them apart. Oh. Okay. So we're letting the power rule backwards because we're integrating. We're doing the opposite of derivatives. So integral and antiderivative are basically interchangeable. So antiderivative means like the opposite of the derivative, and then integral is the opposite of the derivative, so they can say that either way. And this is just trying to show you how it's the same rule but backwards. So the rule here was bring down the n and reduce the power by 1. So we have to do those things in reverse and opposite to go backwards. So what we do is add 1 to the power, and then we divide by the new power. More how people usually think about it, instead of dividing by the new power, a lot of times you end up doing this. You add 1 to the power, and you multiply by the reciprocal of the new power. So those are both the same thing. It's just kind of 2 different ways to present it. So if you want to write the steps out, you add 1 to the power. And then either divide by the new power or times by reciprocal. Those are the same thing. So like if your new power is 3, you can either divide by 3 or you can multiply by 3. Same thing. So let's look at some examples. It's easier than that makes it seem. So x squared. Let's try this. So give me something that has a derivative of x squared. That's what I need. Something that has a derivative of x squared. 1/3 x cubed. So the integral of x squared. So I don't know if you were like reasoning through that or using the rule. But what it would be is add 1 to the power, and then we can either divide by the new power, or multiply by the reciprocal of the new power. But give me something else that has a derivative of x squared. Did you do this yet? You don't know either. What else? So y equals 1/3 x to the third absolutely has a derivative of x squared. What else does? No, not negative. So give me an example. Good. So doesn't that also have a derivative of x squared? Like no matter if I put minus a million here, wouldn't it also have a derivative of x squared? So we don't know what the constant is because whatever constant was here, when you take the derivative of it, is 0 and it goes away. So when you start with the like it's 0 and it's gone, you don't know what number to put here. It could be anything. So what you do is put plus c, and that represents the idea that there might not, it could be a 0, but there might be some constant there that when you take the derivative of goes away. So this could be anything, and it'll still give you a derivative of x squared. So this is the answer with the eraser. So your answer is y equals 1/3 x to the third plus c, or you could say y equals x to the third over 3 plus c. On the gateway, there will be, so we do definite integrals and indefinite integrals.
How do
You
we
don't know the number. That's why you put a C there.
Then how do we know that? It's definitely it's a
How do you know what?
How do we know
Know what?
that someone knows that it could be? Wait, but how do we know if? No, seriously.
Yeah, so I'm not sure if we're trolling or serious anymore.
I
I'm
was
not
not
sure.
as
So what's your legit question?
Like, how does someone know that there is something there?
No one knows. Alright, so I don't know specifically what it is unless I give you more information. But what I'm saying is, so what's the derivative of 1/3 x to the third minus 1? X squared. What's the derivative of 1/3 x to the third plus 1,000? X squared. So when you're going backwards, you have literally no way of knowing if there's a -1 there, if there's a 1,000 there, if there's anything there. It might be a 0. So all you can do is say, okay, yeah, there's some constant. Unless you give me any more information, I can't tell what that constant is. Does that answer your question? It's an unanswered. Look at now. Look, I'm not sure if you're joking around. I'm terrified.
No, just from immediately, like if you write minus c or if I write like plus c squared, it's just like randomly it's just there just because it's not actually it's broke down. Is that minus points?
So
Plus or minus?
Because C is anything, so C squared is just a different constant.
So what if I just make it really?
So c squared isn't wrong. Okay. I'm just checking because I feel like I randomly will put like minus c or something and get marked down.
But people have forgotten the C, and you know, maybe there's 4 on one here, but one year a girl, like I gave her back her test, she didn't put the C on it. She kind of, I think she failed 50 or 60. It was like the first or second attempt. She ripped it up, threw it on my head, and goes, "Screw this!" Like stormed out of the room. Don't do that. You are not allowed to do that. Okay. If I look at the next one, I can't take the integral in that form with the variable on the bottom. And in there's not like a quotient rule for integrals, so that's like a general thing. I don't want that variable on the bottom, so I'm going to bring it up and rewrite this first as 5x to the third plus 6x to the negative third minus 1. And then my job is to, my job is to integrate. So I add 1 to the power, so that'd be x to the fourth. And so the rule is like divide by 4. I think multiplying by the reciprocal is way more common, way more useful. It's way easier to think about. So I'm going to multiply by the reciprocal of the new power, which is 1/4. But there's already a 5 there. So this is really like 1/4 times 5. And I'll clean that up like in the next step. You can. Or you can do 5/4 x to the 4th. I'm just showing like where it's coming from right now. That'll be my next step. Add 1 to the power, -2, divide by the new power. I'll clean it up in the next step. What's the integral of 1? It's x. Because what would you take the derivative of to end up with 1? Is x. So you can check your work fairly quickly on some of these. Like I can look at this and take the derivative and see if I go back to here. 4 times the fourth cancels. 5 stays. Reduce the power by 1. Bring down the -2 times the -3 that's really here. That's a +6. Reduce the power by 1. So like it does work, but I'm not done. What do I still have to do? Plus C. You gotta put the plus C. Because the original function might have been this plus 1, this -10, this plus pi, whatever. We don't know that. That's an acceptable answer, actually. If you wanted, like the multiple choice options would probably write it like 5/4 x to the 4th minus 3x to the -2nd minus x plus c. But this is fine. Questions on 2? Yeah. So the integral, I got to integrate -1. That doesn't really have a power, so I can't use like a power rule. So I'm just kind of thinking through like what would I take the derivative of to end up with the slope or derivative of 1. So if I take the derivative of negative x. Anytime there's a, I'll put this up in a second. But anytime there's a constant, like integral 4 is 4x, integral 10 is 10x. What would I do? For now, that might change. Same question. You said something. No? Okay. This is like a rule that I kind of wish they had pointed out. What's the integral of k? Like k is a constant, any constant. What would you take the derivative of to get k? Kx. Yeah. So if that helps you to write that down as like a special rule, that's cool. Let's just say like the integral of 3 is 3x, and then you're plus c. That doesn't really work with like the power scenario thing. I don't know if you've tried 3 or not, because I've been rambling for a long time. If you haven't tried 3, try 3. Rewrite it first. So you would add 1 to the power. So 1/2 plus 1 is 3 halves, right? It's like 1/2 plus 2 halves. And this is where I don't like divide by the new power, because then you're not even a fraction on the bottom. So I think multiply by the reciprocal is a better general phrase. Just repeat to yourself. Add 1 here, and that'll be a half. Multiply by the reciprocal of the new power. So the reciprocal of 1/2 is 2 times the 3 that was already there, and then plus c. How's that? Yeah. Yeah, but like if you have to do something with that, like if you have to work with that, that's just a mess. It's not wrong. Oh yeah, yeah. So that's not wrong. It's just like if you have to set that equal and solve something, which is going to happen, that's just like annoying. But if you put that in the gateway, it'd be right. It'd be correct. You had your hand up too, man. I'd like it to. Like you're just saying, like go right from there to 1/3 x to the third plus c. It does. I don't really care that much. I think it's probably a good habit to get into, and like remember the dx goes there, but I'm not gonna mark it wrong. Hey, ask again. This one? No, because it's the new exponent that matters. So it's this one. Alright, integral of sine. Well, you guys tell me. What's the integral of sine? What do you take the derivative of to end up with sine? Negative cos. Almost there. You're almost correct. Plus c. What do you take the derivative of to get cos? Sine of x. Plus c. So remember all those rules we had last time that you had to memorize? They all come back around and now they're in reverse. So like the same stuff, just going the other direction. Bring it back. Okay, definite integrals. These are definite integrals because I will get a definite answer. Like before, I didn't have a definite answer, which made Carter very upset. But it was plus C. Like I don't know what it is. I don't know what that constant is. Definite integrals, we're going to get a legitimate answer. It's going to be the area under the curve. And the difference is you'll have numbers in both of these spots. So what you do is we're going to integrate this, and then we're going to do some plugging in. So understand what they're saying here. Capital F is the antiderivative of little f. So when you go from here, I'm going to write it like this. When you go from here to here, you're integrating. And this is telling you the integral of lowercase f is capital F. And then I want you to put the A and B right there. This is a capital F. And then what you do is plug the top in minus plug the bottom in. And that'll get you a number. That number represents the area under the curve. So we'll go through. Is everybody still writing that? Okay. So if I'm doing number 4. My first job is to integrate the 4 minus 6x. And I can just do that right away in this one. This one I'll have to rewrite. But so what's the integral of 4? 4x. Minus. How about the integral of 6x? Add 1 to the power, add 1 to the power, multiply by the reciprocal. What? 3x squared. So that's your integral. That's your new function you're going to be working with. And then I've got negative 2 and 5. So your job is to plug in the top, minus, plug in the bottom. So like you're going 4 times 5 minus 3 times 5 squared. Minus, so that's plugging in the top. Minus 4 times negative 2 minus 3 times negative 2 squared. And then I got to work that stuff out. So this is like 20 minus 75. So negative 55. Minus, this would be negative 8. Minus 12. So minus negative 20. And that's negative 35. So if my answer is negative 35, is more of the curve underneath the x-axis or above? It's under because we got negative. I don't care about the answer. It's the process. Does that make sense what I'm doing? Let's look at 5. Do I erase or not? So I would rewrite this first as like x to the 1/2 minus x to the negative second. Quick word of caution, if you write it like that, it's technically wrong because this dx is only being multiplied by that, the way you wrote it. So you'll notice I put parentheses there all the time, and that's because the dx that way applies to all of it. On a multiple choice, no one's going to know or love or care what you did, but if it's a free response, you want to make sure you put in that part correctly. So now let's integrate. Add 1 to the power is 3/2. Multiply by the reciprocal is 2/3. Minus, add 1 to the power is negative 1. Multiply by the reciprocal. So there's already a negative 1 in front. I'm going to multiply by this negative 1. I'll get a positive 1. And then my job is to plug in 1 and 4, which might be more difficult for some of you than the integrating. Is that first step okay then? So now I'm going to plug in 4 minus plug in 1. So 2/3 times 4 to the 3 plus 4 to the negative first. So we got fractional exponents and negative exponents. Minus 2/3 times 1 to the 3 halves. 1's always a nice one because everything's just 1. That is not an acceptable answer because you can only have the 4 basic operations. Right now you have powers, you have negative powers, so you have to do a little more. But this is good because I feel like it's probably useful to review how to do this. So remember what that means. You take the second root of 4, which is the square root of 4, so that's 2, right? And then you raise it to the power on top, so what's 2 to the third? Probably say 8, yeah, good job. 8, and then 2/3 of 8, so I'm at like 16/3, plus, what's 4 to the negative first? 1/4. Minus, the 1 is nice, because 1 to any power is just 1. Like I square root it, I cube it, I get 15th rooted, 10th power, whatever, it's just 1. Times 2/3. And then again, 1 to any power is 1. And that is an acceptable answer. So I think that's where you're going for. Like, do I have to simplify all the way? You do not. That is a perfectly acceptable answer. On the multiple choice on the AP test, they might like give you a list of 5 answers, and then you can't use this. You'd have to actually figure out the answer, but that would be fairly obvious at that time. That's what you have to do. 4 or 5, those are good. 6. I'm going to use that rule that says I can factor out the 4. What's the integral sign? Negative cos. And then I've got 5 or 2 and 0. So I got to do 4 times. I just need like the triple parentheses. So 4 times negative cosine of 5 or 2 minus negative cosine of 0. And you can't leave it like that because that's not the 4 basic operations. It's just got to be plus, minus, multiply. That's got trig in it, so we're not done. So, cosine of 5 or 2. So 5 or 2, x value. 0. So negative 0 is still approximately 0. Minus cosine of 0. So over here, what's the x value? 1. But it's minus a negative 1. So it's plus 1. So my answer is just 4. But like this is not wrong. That's an acceptable answer also. Pretty sure you guys can do 0 plus 1 and 1 times 4, but you never know. It's a long day. Yeah. Question on 6. Alright, 7 is different. 7 is harder. I feel like I usually don't talk this long. I don't know if you guys are still with me or not, but if you left, come back for this one because it's tough. What they're saying here is, remember that when we integrate, we're accumulating area. So if I'm integrating from like 0 to 3, I'm just accumulating, like as I go. So we start off negative, then it'll be, now it's probably 0, then probably canceled, and I would just keep adding the area until I figured out how much there was, until I get to 3. So what this is telling you is that x equals 1, we've accumulated negative 2 units of area. And then they're saying, okay, what's f of 3 going to be? So I know the derivative. I know what the original y value was. And what I can do is say, okay, at 1, we've accumulated negative 2 units of area. Do I know how to figure out how much area was accumulated between 1 and 3? I do. That's integrated. So if I know where I started, and I know how much I added on to that, that's how I'm going to figure out the answer. So I'm starting at negative 2. And then I'm going to integrate from 1 to 3. And I'm picking those numbers because I started at 1. That's what they told me. And they want to know what happens at 3. So that's why I put that for the end point. The derivative goes in here because that's what you want to integrate. And that's how you would set that up. it's gonna do is we started at -1. This is gonna figure out how much area was accumulated here and add it to the -2 that was there where you started. Is that setup? Question on the setup? We'll practice these because these are probably the hardest for most people. And then I just work this out. So it would be 1/3 x to the third minus 2x, 1 to 3. And I think right now your time is better spent practicing problems than watching me do that. Unless you're telling me you want me to do that. Like you're just plugging in at that point. Is that fair enough? So I'd like you guys to get started. I guess I'll start when I finish. Not bad. For the homework. Can skip the calculator active. Now let's just go up to 12. Like, don't worry about the test prep. We'll get into that tomorrow. So you're only going to 12 and you're skipping the calculator active. Yeah. I know that at 1, my value, let's say, okay, now I'm going to go, if I want to know the value of 3, I need to know what I started with. And then how much area I accumulated between. And then add those two. So we got to figure out forward. This is a definite. So there's no C. That's like the one we just did. Like on number 1,